Here is an explanation for the answer to final exam, question number 68 in Electronics Demystified, 2nd edition. If you have the printed book, please see page 431. We're talking here about a substance that dilates the magnetic flux compared with the flux density in a vacuum. Well, let's start out by imagining a coil of wire in a vacuum carries a certain amount of current, thereby producing a certain amount of magnetic flux. We can place various materials inside this coil. Rods of materials of various substances such as iron, steel, powdered iron, or even wood or wax, or even cardboard cylinder just to wrap the coil around to hold it in place. Depending upon the nature of the material that we put inside of this coil, the magnetic flux in and around it will grow either more or less dense. So the flux density will increase or decrease, thereby resulting in a more or less intense magnetic field in the vicinity of the coil. Well, the type of material that we normally would place inside of a coil is called ferromagnetic. It's like iron, steel, powdered iron, and various alloys of those metals. Ferromagnetic materials result in electromagnets. They also increase the inductance of a coil of wire compared to what it would be in air or a vacuum. So ferromagnetic materials have a lot of useful properties, and they operate by increasing the flux density. Well, that's not the choice that we want here. We're talking about stuff that actually dilates the magnetic flux. That type of material is far less common than ferromagnetic material and is much more difficult, in fact, to get very much of an effect. That's called a diamagnetic material. So the correct answer to this question is choice A. A diamagnetic material will actually dilate or reduce the flux density compared to what it would be in a vacuum. Well, what types of materials are these? Well, wood and wax will both slightly decrease the flux density compared with a vacuum, but neither of them will do it very much, certainly nowhere near the extent to which a ferromagnetic material can increase the flux density. However, a substance called a superconductor has the property of being extremely diamagnetic. Now that isn't discussed in this particular book, but it is discussed in my book Alternative Energy Demystified. A superconductor is what we get if we chill a metal like copper or iron or silver down to almost absolute zero. It loses its resistance and conducts, in effect, perfectly. A substance of this type has the property that scientists call perfect diamagnetism. Perfect diamagnetism. Well, in the universe, nothing is absolutely perfect. But a perfectly diamagnetic material expels almost all of the magnetic flux that exists around it. And the interesting thing about that is it results in a material that magnets will repel, whether it's the north or the south pole. Here, one of these poles is north, one of them is south. Because we don't know the current direction, we can't specify here, and we don't know the sense of the windings of the coil. But if we have an electromagnet like this, or an ordinary magnet, and we place a substance, a superconducting substance near it, that magnet is going to repel that substance with quite a lot of force, and that is how the magnetic levitation or maglev train works. Perfect diamagnetism. But in any case, the choice that answers this question correctly, again, is choice A. A diamagnetic substance will dilate magnetic flux compared with the flux density in a vacuum.